Alright, welcome back. In this video, we're going to go over how to solve or how to graph linear equations. And like I said last time, we are going to graph equations that are usually in the form y equals mx plus b. This is called slope-intercept form. Let me just write that down, because if you're going to watch any other videos, you're going to be looking for this slope-intercept form. And this is where m is the slope and b is the y-intercept. So notice that there's going to be a rule that's going to tell us to take some x and multiply it by a number, m, that's our slope, and then we're going to add or subtract a b, that's going to be our y-intercept. And we're going to look at a few examples, and I'm going to show you 3 different ways how to graph these. So the first way is going to be, it's going to work for any equation, actually. It's going to work for if it's absolute value or quadratic or more complicated equations. And then I'll show you a shortcut that just works for linear equations, and then I'll show you how to use Desmos as a graphing calculator tool. And these are the first examples that we're going to work out. So let's go ahead and look at each of these. So here's our first one, y equals 2x minus 3. So the first way to graph these is to think about this as a rule. This is telling us to take some x, and we're going to multiply by 2, and then we're going to subtract 3, and that's going to give us our y value. So the most basic way to graph these is to set up a table. And you could do this again with any type of equation. And x is called our independent variable because it is free, it's independent, it could be anything I want. And usually we'll put in 0, and we'll put in a few positive numbers, and then we will put in a few negative numbers, like so. So we get an idea of what's going to happen to the output, to the y, which is our dependent variable. So when I put 0 in here, I'm putting 0 in here for x, and saying 2 times 0 minus 3. What does that come out to? Well, 2 times 0 is 0, minus 3, that's going to come out to negative 3. And then maybe we put in a positive number. So if I take this and I put in a 1 there. 2 times 1 minus 3, what is that going to give us? That's going to give us negative 1. And then if I put in a 2 in there, 2 times 2 would be 4, minus 3 would be 1. And if I put 3 in there, 2 times 3 would be 6, minus 3 would be 3. And already with the y values, you should probably start seeing a pattern. See how much these go up by? If I put in negative numbers, you can see that if I put in negative 1, it's going to be 2 times negative 1 minus 3 is going to be negative 5. Then I would get negative 9. All right, so now that we have these x and y coordinates, we can plot these. So this is the point 0, negative 3. And 0, it's not going left or right. It's going down to negative 3. There it is. And 1, negative 1 would be right there. And 2, 1 would be there. 3, 3 would be there. And we can plot the negative ones. Negative 1, negative 5, negative 2, negative 7, and negative 3, negative 9. That would be off our chart here. Would be down there. And I could have plotted or put in any x value I want, fractions and decimals and, irrational numbers, pi, and so on. So we would fill in all these gaps. And you see these points lie on a line. So I draw a straight line that goes through those. And that's what the graph of this equation looks like. So a couple things to notice is that this right here, 0, negative 3, is special. That's our y-intercept, and that's the constant that we have here at the end, the negative 3. The other thing to notice is that these numbers are going up by 2 as these numbers go up by 1. So this is our rise and this is our run. It goes up by 2 as these go up by 1. 2 over 1 gives us our slope, which is 2. And we can see that the 2 out in front of the x, the m here, is the slope for this line. So it goes up 2 over 1, up 2 over 1, up 2 over 1, and so on. So it follows this pattern. So we can use those shortcuts to make the graphing easier so we don't have to make a table every time. All right, so here's our second example. And just like before, we like to put in 0. We like to put in some positive numbers, and we like to put in some negative numbers. So we're using this table method. And this is going to be our x's, and we and are going to plug them in and figure out what y is. If I put 0 in here, the opposite of 0 is 0 plus 2. That's going to be 2. If I put 1 in here, I get negative 1 plus 2, which is 1. If I put 2 in here, I would get 0. If I put 3 in here, I would get negative 1. And if I put negative 1 in here, I would get 3, and then 4, and then 5, and so on. And so now we can plot those points. But again, notice here we got a shortcut. What does the shortcut say? Well, the shortcut is that we use this first. We use the y-intercept, and we plot that. That's 2. And then we look at the slope. So what's the slope here? Well, it's got a negative out in front. We can write that as a negative 1. And the slope would be negative 1. When we are graphing these, we want to think of the slope as a fraction. So if it's not a fraction, we can always write it as a fraction over 1. And then the top number is going to tell us the rise, and the bottom number is going to tell us the run. So if we write it as negative 1 over 1, that's telling us to go down 1 to the right 1. And we always start from the y-intercept. So we start from the green point, the y-intercept, and then the slope is going to give us directions to every other point. So in this case, we're going to go down 1 to the right 1, plot, down 1 to the right 1, keep following the pattern. Or we could write the slope as 1 over negative 1, and that tells us to go in the opposite direction, go up 1 to the left 1, up 1 to the left 1. And you should notice that that's the same points that I have here, 1, 1, 2, 0, 3, negative 1, negative 1, 3. So we don't need to use the table anymore. We could just use the shortcut, use the y-intercept, plot that, then figure out what the slope is. If the slope is a fraction, that's great. You're going to use the rise and the run. If the slope is not a fraction, if it comes out to an integer, you're going to write it over 1. And then read the top number as the rise, how far up or down you go, and the bottom number as the run, how far left or right you go. And plot the points. And all you have to do is plot like, about 3 or 4. And once you see that the pattern, you're just going to connect them with a smooth, straight line here. There we go. And that's it. So that's how we graph the lines. With example 3, now this one, what's missing here? We don't have a b here, but we could write it as 0. So if there seems to be a part missing, it's usually because it's a part missing, and you can think of that as a 0. So here the y-intercept is 0. And what is the slope? Well, here the slope is 1/2. It's already a fraction. Remember, the top number tells us the rise, the bottom number tells us the run. So it's telling us to go up 1 over 2, up 1 to the right 2, up 1 to the right 2, or we can go in the opposite direction, down 1 to the left 2, down 1 to the left 2, and now we've got our points. Like so. So that's how you can graph using either a table or using the shortcut, using the y-intercept and the slope. Now let's show you how to use Desmos. In case you're still having a little difficulty, you can check with Desmos, although I still want you to try to do it by hand. So let me pull up the Desmos screen. All right, so here's the Desmos screen. And notice that with Desmos, we can type in y equals. One of them was, I think, 2x minus 3. So there is y equals 2x minus 3. The nice thing about Desmos is you can shift the graph around. You can click on it. You can find the y-intercepts pretty easily. And you could also graph multiple lines here. Like if I have y equals 1/2 x, I can just type it in like that. Make sure you type it in correctly. There's our 1/2 x. And it will even show you where 2 lines intersect, which we're going to find very useful when we start solving systems. So you can see the blue line, the red line. We'll do one more example. Y equals, let's say, 4. And where is that line? Oh, there it is. Y equals 4 is just a horizontal line. It has 0 slope, and it has a y-intercept at 4. And we can also do some negative slopes. Y equals negative 2/3 x plus 6. Oops, gotta make sure we're typing in here correctly. Always make sure your x is over here. 2/3 x plus 6. Again, we've got a y-intercept here, an x-intercept. That's going to help you to graph it. And again, you could click on any other points. If you're graphing two lines, you can find out where they intersect. So that's how you use Desmos. Desmos will also be useful because sometimes we're going to have equations that are not solved for y. Desmos can handle those fine as well. So even if it's not solved for y, if it's in standard form, Desmos can still graph them, as you can see with this black line. All right, so now we're back from Desmos, and again, I'll show you a few more to do by hand here. And if you want to, you can go with me to practice these. I'll try to take it a little bit slower here. So our first one is y equals negative 2x minus 5. So the first step is to find the y-intercept. So I'll make a note here. Ask yourself, what is the y-intercept for this equation? Hopefully you said negative 5. Okay. And then we also want to find the slope. What is the slope for this equation? Hopefully you said negative 2. What we're going to do is we're going to start with the y-intercept. So go on the y-axis, go down to negative 5, plot it. Then we're going to change the slope, make sure it's a fraction. If it's not a fraction, we write as a fraction over 1. The top number will tell us the rise. The bottom number will tell us the run. And this is telling us negative 2, 1. So that's actually off our grid here. So that's not a problem though. We can switch the negative and put the negative on the bottom. And that's going to tell us to go up 2 and to the left 1. So up 2 to left 1. There's another point. There's another point. There's another point. And then again, after you graph about 3 or 4, that's all you need. And you can graph the line like so. For number 2, what is the y-intercept? The y-intercept is 1, so you plot a point. What is the slope? The slope is 5, which we can write as 5 over 1. And what does that tell us to do? It tells us to go up 5 to the right 1. So there's another point. I can't do it again or else I'd be off the grid. So when it's positive over positive, you can switch both the signs. So 5 over 1 is the same as negative 5 over negative 1, because two negatives, when you divide them, give you a positive. So that tells us to go down 5 to the right or to the left 1. And there's another point. And we connect. Oops, try to connect with a straight line here. Let me fix that. Erase. And there's our line, like that. Like I said, y equals 4. We did this on Desmos. This is going to be a horizontal line because we can think of this as y equals 0x plus 4. So the y-intercept here is 4, and it's got 0 slope. It's also telling you that the y-coordinate always has to be 4. So here's the point 0, 4, 1, 4, 2, 4, 3, 4, negative 1, 4. All these points that are on this line, if you write them out, have a y-coordinate of 4. What do you think is going to happen if we have x equals a number, like x equals negative 2? Well, when it was y equals, we got a horizontal line. When it's x equals, we're going to get a vertical line. So x equals negative 2, that doesn't look like y equals mx plus b. We can't put it in that form, but this is kind of a weird one because this is saying x equals negative 2. Okay, here's a place where x equals negative 2. X is negative 2 here as well, and down here, and all along this vertical line. So x equals negative 2 would be a vertical line. And as a quick mnemonic to help you remember this, I use the mnemonic device HOI-VUX. The HOI stands for horizontal lines have 0 slope, and they're going to be y equals a number. Let's call that number b. And VUX, vertical lines, have undefined slope, and they're going to be x equals some number. We'll usually call that a. So that's a quick reminder, quick mnemonic device to help you remember the difference between horizontal lines and vertical lines, which ones have zero slope, which ones are undefined if you're given an equation, or you have to find the equation. Okay, the last part here for graphing, we want to graph ones that are in standard form. And like I said, you can do this in Desmos, but I think you should give it a shot and see if you can do it by hand, because these we want to solve for y. So we're going to solve these for y. So solve for y. Here I've got 2x plus y equals -5. And when you're solving this for y, we got 2x plus y equals -5. First thing you do is to move the x to the other side, either by adding or subtracting, usually subtracting like so. And that's going to give us y equals, let's put the x's first, y equals -2x minus 5. And then there's any coefficient in front of the y, we would divide by that coefficient. Here there's no coefficient, so we are good to go. Now that we got into this form, we can plot it. So we've got -5 here. That's the y-intercept. Always go with the y-intercept first. And the slope is -2. Think of -2 as -2 over 1, down 2 over 1. That doesn't help. We go up 2 to the right 1. A few more points there, and there is our line. So it should look like that. 5x minus y equals 2. Let's see what this one looks like. Pick a different color here. So 5x minus y equals 2. I'm going to subtract 5x from both sides. That's going to give me -y equals -5x plus 2. And then let's switch all the signs, divide everything by -1. That's going to give us y equals 5x minus 2. So the y-intercept here is -2. The slope is 5, which we can write as 5 over 1. That tells us to go up 5. 1, 2, 3, 4, 5 over 1. There's another point. And 2 points make a line. And so there's what our equation should look like. And let's try number 4 here as well, because for number 4, I've got another number in front of the y. So you're always going to move the x's over first. That gives us -2y. Put the x out in front. Put the 2 here. And then we're going to divide by whatever's in front of the y here. It's going to be the -2. We think of this -x as a -1. And after we divide by -2, we're going to have 1/2 x, because a negative divided by negative is positive, and that's 1 over 2. And then 2 divided by -2 is going to be -1. So there's what our equation looks like in slope-intercept form. And we're going to graph that. There's -1. And then the slope is 1/2, so we go up 1 over 2. There's a point. Or we can go down 1 to the left 2. There's another point. There's what our equation and the graph for it should look like. The next thing I want you to do is to go in the opposite direction. So what if I give you a graph and you have to write the equation for it in slope-intercept form? So now you have to do the opposite. So you have to look at the graph, you have to get the slope, and you have to get the intercept. Well, the first thing you're going to do is to get the intercept, because the ones I give you, the intercept is going to be an integer. It's going to be a nice point. So we want to find b first. So let's go ahead and find b for number 1. What is b? Where is it crossing the y-axis? So it looks like b here is 2, and we can mark that as a point. And notice that along these lines, we don't have any points that are marked for us. So we have to find some nice points. By nice points, I mean points that are on the corners of the boxes here, of the squares. We want to use the lattice points. So this appears to be another one. And if I use these 2 points, what would the slope be? I'm going up how many? Up 2 over 1. So the slope here would be 2 over 1, which reduces to 2. And you want to see if that pattern continues. So up 2 over 1, up 2 over 1. and you're always hitting the line. So the slope here also is 2. So the equation would be y equals 2x plus 2. For number 2, what is the y-intercept? The y-intercept here was negative 2. All right, now we're going to go in the opposite direction, and we're going to do the find the equation given the graph. So first thing you want to do is to find the y-intercept, and the y-intercept for this one is at negative 2 because it's below the y-axis. And the slope here, well, we can use the negative 2 as one of our points, and if we go along this line, we want to find another nice point, and there should be several of them that you could use. Like we could go all the way up here, but we want to try to get as close as possible. So it looks like this is a nice point. We want a point that's on the corners of the boxes, a lattice point. So from the first point, from the y-intercept to that point, I'm going up 2 over 1, and that's going to reduce to 2. Now you want to see if that pattern continues. So I still go up 2 over 1. If I go up 2 over 1, I should continue to hit the line every time. And I do. So the equation here is going to be slope is 2, and I put my x, and then the y-intercept is negative 2. So there is the equation. Y equals 2x minus 2. And you'd be able to check with Desmos if you wanted to. Just type this in and see if you get the same graph. For number 2, what is the y-intercept? Here the y-intercept appears to be positive 2. And the slope, so I can go down, and how far over do I have to go until I hit a corner? It looks like this point right here. So I'm going down 1, and I'm going over 1, 2, 3, 4. Let's just check in this direction. 1, 2, 3, 4, up 1. All right, so it looks like I'm going down 1 to the right 4. So my slope is going to be negative 1/4. So when I write the equation here, it's going to be y equals negative 1/4 x plus 2. For number 3, what do we find first? We want to find the y-intercept. So draw a little dot there. The y-intercept is 1. Go along the line until you find another nice point. Here's a nice point. We're going down 2 over 1. Make sure it continues to check that that is the correct slope. And we are going down 2 to the right 1. The slope is negative 2. Write the equation y equals negative 2x plus 1. For number 4, here is my point. The y-intercept appears to be at 3. And if I go down and over, you might think, oh, let's say you make a mistake, and you think that is the point where it crosses. So maybe you think that the slope is 3, because it goes down 3 and then to left 1. But does that continue? So if I go down 3 to left 1, it doesn't hit the line. So you can see that that is not the correct slope. So that's why I always check to make sure. So even though it looks like it's close at this point right here, we have to go a little bit further until we find a nice point. It looks like this is the only option that we have. So this point right here, 1, 2, 3, 4, 5, down 5, and to the left 2. Notice that the slope here is positive, so we should have a negative over negative. That's going to give us a positive. The equation here is going to be y equals 5/2 x plus 3. And again, when you're doing these, you can check with Desmos. So hopefully that helps you in how to come up with the equation given the graph. Okay, the last thing you need to do is to write the slope-intercept form of the equation given 2 points. So there's a way to do this just algebraically, but I'm going to start by doing this graphically. So it's always a good idea, if you don't like the whole algebra and the math and the equations, to just plot these points. So, and you can even do this on Desmos. Desmos will plot the points. 1, 5, it goes up here, and 4, -1 goes down here. So I can plot those points. What I need to do is I need to find the slope and I need to find the y-intercept. So the first thing I will do is to find the slope. So how far down am I going? 1, 2, 3, 4, 5, 6. It's going down 6 and it's going to the right 3. So that means that the slope is -6/3, which reduces to -2. So really it's going down 2 over 1, down 2 over 1, down 2 over 1. And so now I can fill in those points. And once I got those points, I can extend it in this direction so I hit the y-axis and I can go up to the left 1. And now I know what the y-intercept is because it's going to hit the y-axis right there at 7. So I've got a slope of -2 and I've got a y-intercept at 7. So I'm going to show you an algebraic way to solve these, but you could do these just by graphing the points, figuring out the slope, and filling in all the points until you get the y-intercept. But again, I need to have your final answer. What is the equation here? And the equation for this one is y equals -2x plus 7. Now, how do we do this with a formula? Well, we got two formulas. So remember, we've got the slope formula, y2 minus y1 over x2 minus x1. And we've got our slope-intercept form, y equals mx plus b. So when you're given 2 points, we don't know what the y-intercept is usually right away. So we got to find the slope first. So I'm going to work out number 1 again. And this time I'm going to do it algebraically with the formula. So let me erase this and label these guys. So this will be our x1, y1. This will be our x2, y2. And we've got 2 points here. So y2 is -1 minus 5. X2 is 4 minus 1. That gives us -6/3. That gives us -2. Okay, so now we've got the slope. So there's the first part. So first step is to find the slope. Second step, now we're going to use this equation y equals mx plus b with one of our points. So we're going to use a point. Let's say I want to use the point that has probably not so many negatives in it. I want to use the smaller numbers. So I can either use the 1, 5 or I can use the 4, -1. So either point will work. And I'm going to call this my x and this is my y. And now I have everything I need to plug into y equals mx plus b. I don't know what the b is, but I know what y is, I know what m is, I know what x is. What is y? Well, if I'm using this point, 1, 5, y is 5. What is m? And we found up here, m is -2. What is x? X is 1. And so now I have 5 equals -2 times 1 plus b. 5 equals, simplify this, solve for b. b is equal to 7. Now I know what b is, and I know what m is, and I can write the equation. Y equals -2x plus 7. I get the same answer either way I do it. This way requires you to solve for the slope and solve a little equation. This way just requires you to plot the points, find the slope, and then plot some more points, and then write the equation. So you can pick which way you like better. From now on, I'm going to do the second way again to show you number 3. Okay, so here's the algebraic method again. So let's call this x1, y1, x2, y2. And we are going to find the slope first. So first step, find the slope. Find slope. And how do we do that? We got our slope formula, which is going to be -1 minus a negative 2 over negative 4 minus 0. Simplify it. That gives us negative 4 there. And that gives us negative 1/4. So now we have the slope. After we have the slope, let's use one of the points. Both pair of points have a negative numbers. This one is a little bit smaller. So I'm going to use 0, negative 2, since the numbers there are a little bit smaller to work with. And now I'm going to use y equals mx plus b. Y. What is y? Y is negative 2 equals negative 1/4 times x. X is 0. That's handy. Plus b. And, well, negative 1/4 times 0 is just 0. So on the right side, just get b. B is negative 2. So this one I didn't have to actually solve for b. If you notice right away, this gives you the y-intercept, 0, negative 2. If I would have realized that, I wouldn't have to solve it. So we have the slope, we have the y-intercept. Let's write the equation. Y equals negative 1/4 x minus 2. And if you wanted to, you could plug this into Desmos or graph it. Here's 0, negative 2. And the slope is negative 1/4. So it's going to go down 1 to the right 4, or up 1 to the left 4, and up again like that. So you can see it does go through negative 4, negative 1. There's the equation, there's the graph for it, and you can see that both of these points are on this graph. So we know we did it correctly. So the thing about these problems is you should always be able to check your answers, either by hand or with Desmos. Let me know if you have any questions, and we'll see you next time. Bye!